Hello students, today we'll do the discussion of test number 18. Okay, I hope all of you did well and doing proper practice, okay, from your book. So let's see what are your doubts in test number 18. So your doubt number in test number 18 is 48, 52, 57, 61, 63, 64, 66, 67, 70, 71. Lot of doubts you have asked. 71, 73. That's it. So 73. Total number of doubt is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total is 11 by 45. Okay. So this much doubts you have asked. That is test number 18. Topic was chemical equilibrium. And even though this is an easy chapter, you have asked a number of doubts. It reflects you are not doing proper practice. Okay. Or you are feeling some difficulties might be. See, question number 48 first. Question number 48. Let's see. For the synthesis of ammonia by the reaction N2 plus 3s2 in the Haber's process, the attainment of equilibrium is correctly predicted by the graph. We have 1 mole of N2, 3 mole of H2, and it forms 2 mole of ammonia. Okay. If you plot a graph between time and concentration on y-axis, time on x-axis. So we have 3 moles of hydrogen, 1 mole of nitrogen. So 1 mole of nitrogen, 3 mole of hydrogen, and then 2 moles of ammonia. So this is the point, this is the graph. This is the time where time of equilibrium we can say. This is for ammonia, this is for hydrogen, this is for nitrogen. See where this type of graph is there. Okay, ammonia will be formed which is 2 mole. Ammonia which is formed as 2 mole. Where is this graph? Hydrogen is 3 mole, nitrogen is 1 mole. We have taken this one. So where is the exact graph? Nitrogen, hydrogen, and ammonia. If this is hydrogen, hydrogen must be at the top. Nitrogen, so actually none of the graph is correct graph. The graph nature will be like this, but little bit, alright, somehow similar graph is plotted at A. So this we can say the answer is G. Okay. See, let's say 1 mole we have taken, 3 mole we have taken, 0 mole we have taken. This is 2x. This is 3 minus 3x. This is 1 minus x. Let's say this x is 0.1. Let's say this x is 10%, 0.1. So this will be 2 into 0.1. This will be 3 minus 3 into 0.1. This will be 1 minus 0.1. So this is close to 0.9. This is close to 3 minus 0.3, or it is 2.7. This is what 0.2. Now see, 0.2 at equilibrium, their concentration of ammonia is 0.2. concentration of hydrogen is 2.7. If we see the concentration of hydrogen is 2.7, concentration of nitrogen is 0.9, 0.9, concentration of nitrogen is 0.9 and ammonia is 0.2. So if we consider by this, then we'll have this graph as time over here, concentration, this will become hydrogen, this will become nitrogen, this will become ammonia. So this will become ammonia, this will become nitrogen, this will become hydrogen. If we'll take x is equals to 10% or 0.1. If x value will become 0.7, suppose. If x is 0.7, this will become 2 into 0.7, 1.4. Then nitrogen will be 1 minus 0.7 is 0.3. Now see, over here now ammonia concentration is more at equilibrium, nitrogen concentration is less. For such conditions, this graph is valid graph. Since nothing is given whether x is this much or x is this much, alright, so therefore we can say, alright, none of the graph is correct. However, if we take Kc is less than 1, if Kc is less than 1, then this graph is correct graph. If Kc is greater than 1, then this graph is correct graph. So 48 will take G only. Next graph, next doubt of yours is 52. So next is nothing, it is 52 at 527 degrees Celsius. We will discuss 52 at 527 degrees Celsius. The reaction given below is Kc is this much. So NH3 gives rise to half of N2 plus 3 by 2 H2 and Kc for this reaction is given 4. What will be the value of Kp for the reaction? Reaction is N2 plus 3H2 gives rise to 2NH3. So what will be the Kc value for them? This is equals to 1 by Kc square. Okay, this will be the value of Kc dash of this reaction. So Kc dash we know that is 1 by 16. We know that. Therefore, since we know that Kp is equals to Kc into RT to the power delta Ng. So this is equals to Kc. Kc dash is equals to how much? 1 by 16 into RT to the power delta Ng, that is minus 2. This is equals to 1 by 16 into 1 by RT. RT value will take over here, that is R into T. T is how much? T is 527 plus 273. 7 3 10 1 2 3 1 7 0 6 2 8. So 800. This is equals to 1 by, this is whole square. So this will be 1 by 4 times of R 800 R whole square will be the value of Kp. So see where is the answer? So answer given is, which one? Answer given is 52 is C. So C is correct answer. Then question number 57. 57 is for the reaction H2 and I2 gives rise to, for the reaction H2 and I2 gives rise to twice of HI or what? See. (57) H2 plus I2 gives rise to twice of HI. The equilibrium constant changes with, since there is delta Ng is 0, 2 moles product side, 2 moles reactant side. So there will be no change in change in their equilibrium constant or equilibrium by applying pressure or by decreasing pressure, total pressure, no, catalyst will not change. Concentration again over here 1 mole, 2 mole, over here 2 mole, no change. So only temperature is the right answer. So what does it mean? If delta Ng is 0, there will be no effect of pressure, no effect of catalyst, no effect of concentration, but only temperature matters, because this is formation, and for formation delta H is negative. If we increase temperature, their equilibrium constant will decrease. Okay, so answer is D. Question number 61. Then question number 61 is what? In the reaction X gaseous plus Y gaseous gives rise to 2Z gaseous. 2 moles of X, 2 moles of X, 1 mole of Y, and 2 mole of Z is taken. 1 mole of Z are placed in 10 liter vessel are allowed to reach equilibrium. The final concentration of Z is 0.2 molar. So this is allowed to reach at equilibrium. Let's say X is the degree of dissociation. So this will be formed as 2X. This will be 1 minus X. This will be 2 minus X. Divided by 10 liter, divided by 10 liter, divided by 10 liter. So at equilibrium, Z is equals to, the concentration of Z is equals to 1 plus 2x by 10. Okay, and this 1 plus 2x by 10 value is given. This is how much? It is given 0.2. Okay, so this concentration value is given as 0.2. Now we will calculate the final concentration Kc for the reaction. Kc for the reaction is how much? So if we use this, we will get the value of X. 1 plus 2x by 10 is equals to 0.2. So 1 plus 2x is equals to 2. 2x is equals to 1. Then x is equals to 1 by 2. So we will get the value of x. X is equals to 0.5. If we put over here, this will get how much? 2 minus 0.5 by 10. That is 1.5 by 10 is 0.15. This value how much will get? 0.5 by 10 is 0.05. Okay. So Kc value is equals to, that is 2Z, molar concentration of 2Z or molar concentration of Z whole square divided by molar concentration of X into molar concentration of Y. This is equals to 0.2 whole square divided by, okay, 0.15 into 0.05. This is equals to 0.04 divided by 0.15 into 0.05, that is 7500. This is the value. So this will become that much, that is 400 by 75. This is equals to 25 3s are 75, 25 1s are 25, 15, 25 6, that is the answer is 16 by 3. Where is the answer? C, 61. So answer is C. Okay, so 61 answer is C. Now question number 63. We'll go for question number 63. The equilibrium constant for the reaction is this. A system is a equilibrium at this one. What is the concentration of this? Now see, we have CO gaseous plus 2H2 gaseous gives rise to CH3OH gaseous. This is also gaseous. And we have given, there is Kc for the reaction. Kc for the reaction is given 10.5. Okay. A system at equilibrium has CO is this much. Equilibrium concentration of CO. Equilibrium concentration of CO is 0.250 molar. Equilibrium concentration of H2 is given 0.120 molar. Then find out the equilibrium concentration of CH3OH in this reaction. So simple will write Kc is equals to molar concentration of CH3OH, molar concentration of CH3OH divided by molar concentration of CO into molar concentration of H2 whole square. This is equals to CH3OH concentration we need to calculate divided by CO molar concentration is 0.250 into Molar concentration of H2 is 0.120 whole square. This the value is 10.5. Solving this relation, you'll get the value, you'll get the answer. So solve this value, you'll get the answer. And then their answer is given what? 63. A. So their answer is given A. If you'll get the value A, that's all right. Calculate the values and get the answer. Simple. So this is question number 63. So 63 answer is A. Then after question number 64. For the reaction 2A gives rise to B plus 3C. 64. Question number 64 is, when sulfur in the form of S8 is heated, it gets converted to S2. S8 falls. So 4S2. Alright. 4S2. Now S8 is converted to this and their pressure falls by 30% from 1 atmospheric. So initial their pressure is taken as 1, it was 0. Now it is 4x, it is 1 minus x. So 1 minus x is equals to 0.7 because falls by 30%. So 70% is left out. So 0.7. So this value will be 0.7. So x value will be how much? 0.3. So we'll get over here 4 into 0.3 is equals to 1.2. Alright. So 1 minus x is 0.7 and 4x value will be 4 into 0.3, that is 1.2. Therefore, what we need to calculate? We need to calculate the value of Kp. Kp is equals to 4x square, 4x power 4, that is 1.2. 1.2 power 4 divided by 0.7. So calculate this value. 1.2 into 1.2 into 1.2 into 1.2 divided by 0.7. Calculate the value, get the answer. That is the value of Kp. Whose answer is given A? Check that answer. Question number 66. For the reaction 2A gives B plus C. 2A gives rise to B plus C. This is 3C. At given temperature, Kc is given. So Kc is given 16. What must be the volume of the flask? So volume of the flask you need to calculate if mixture of 2 moles of each of A, B, C exists at equilibrium. So this is 2 mole, this is 2 mole, this is 2 mole at equilibrium. Okay. So 2 by V, this will be 2 by V, this will be 2 by V. So Kc for the reaction is equals to 2 by V into 2 by V to the power 3 divided by 2 by V to the power 2. Okay. Solve this relation, you will get the answer. Kc is given, volume you need to calculate. Solving this relation, you will get the answer, and their answer is given as B. So you will get might be B. You check the calculate and get the values of this question. Next is question number 67. Question number 67. At 87 degrees Celsius, following equilibrium is established. H2 gas yes plus sulfur solid gives rise to H2S gas yes, Kc is given 0.08. If 0.3 mole of hydrogen, 0.3 mole of hydrogen, 2 mole of sulfur is used in 2 liter vessel, what will be the concentration of H2S at equilibrium? This will become 0, and if this will become 0, so now it is x, this will be 0.3 minus x. Okay, so divided by 2 liter, Kc for this reaction can be written, this is solid, therefore their concentration is taken as 1 constant. So this will become how much? X by 2 divided by 0.3 minus x by 2. This 2 and 2 is cancelled. Kc is given 0.08 is equals to x divided by 0.3 minus x. Alright, calculate to solve this equation, you will get the value of x and then you will find the concentration of x. So molar concentration of H2S at equilibrium must be x by 2. You can calculate. This is the question number 67. So answer of 67 is given as 1. So check that answer after calculating the value and verify. Next is question number 70. Question number 7070. The equilibrium constant Kc for the reaction is this 70. Equilibrium constant Kc for the reaction is SO2 plus NO2 gives rise to what? SO3 plus NO, all are gases, and Kc for the reaction is given 16. Okay, if 1 mole of each of all 4 gases is taken in 1 decimeter cube vessel, the equilibrium concentration of NO would be 1 mole, 1 mole, 1 mole, 1 mole. Each gas is taken as 1 mole, 1 mole. Their Kc value is given 16. In 1 decimeter cube, that is 1 liter. So 1 mole of which 4 gases are taken. Then after equilibrium, it will become 1 plus x. After equilibrium, it will become 1 plus x. This is 1 minus x. This is 1 minus x. Okay. Then Kc, which is 16, is equals to 1 plus x whole square divided by 1 minus x whole square. Solve this equation to get the value of x. We'll get the value of x. Therefore, equilibrium concentration of NO will be 1 plus x. We'll get the answer. So answer of this is given D. Check the answer after calculating and then mark the correct answer. This is question number 70. Next is question number 71, which is theoretical question. On increasing temperature, the rate of reaction always increases. Rate of reaction always increases, no matter whether it is exothermic reaction or endothermic reaction, because increasing temperature will increase the number of collision or effective collision, and therefore their rate of reaction increases. Next is question number 73. 73 number question is what? See now, 73 number question. (73) 5 moles of SO2. SO2 we have used, O2 we have used. This will give rise to SO3. 2SO2 plus O2 gives 2SO3. So 5 moles of SO2 and 5 moles of O2 are used. Allowed to react at equilibrium, it was found that 60% of SO2 is used up. This will become 0. This is 2x. This is 5 minus x. This is 5 minus 2x. And now 60% of SO2 is used up. So 5 minus 2x is left out, which is only 0.4. 40% only. So this value will be 0.4. So we'll get the value of x. That is 2x is equals to 5 minus 0.4 is 4.6. So x will be 2.3. So value of x will get 2.3. So this value will get 2 into 2.3. That is what? 4.6. This value will get 5 minus 2.3 is 5 minus 2.3 is 2.7. So we'll get this value as 2.7. Now what you need to calculate? If the pressure of equilibrium mixture is 1 atmospheric, the partial pressure of oxygen is, total pressure of mixture is 1 atmospheric. So partial pressure of oxygen you need to calculate, which is number of moles of oxygen by total moles into pressure, total 1 atmospheric. Number of moles of oxygen is 2.7 divided by total moles will be 0.4. Total will be 0.4 plus 2.7 plus 4.6. It will be how much? 4, 6, 10, 17, 7 is 1, 5 to 7. So this is what? 7.7. So total mole is 7.7 multiplied by 1 atmospheric, that is 27 divided by 77. Get the value where it is. So 27 divided by 77 is approximately 0.41. So we'll get the answer, which is C. 73 answer is C. No problem. So we'll get the answer of 73, which is answer C. Okay. So this is all about your all the doubts. No more doubts in this paper. Okay. Thank you very much. I hope you understood how to solve the questions on chemical equilibrium chapter itself. Okay. Thank you very much. Thank you.